We're going to balance another equation by the half reaction method. This one we're going to do is number 15 from the extra practice posted on the website. So first I'm going to split this into two reactions. I'm going to split it into CrO3 becoming Cr plus 3, and then we're going to write selenium becoming SeO3 minus 2. When I come back over here, there's two chromiums on each side, so I don't need to balance that. I need to add some waters in order to balance the oxygen, so I'm going to add 3 H2Os to the product side. After I add the 3 waters, so that solved the oxygen problem, but now I need to come over here and balance out the hydrogens by adding 6 hydrogen ions. And then when I add those 6 hydrogen ions, it's going to be balanced in terms of atoms, but not balanced in terms of charge. This side would have a charge of positive 3. This side would have a charge, there are 6 positive hydrogen ions, so it's going to be plus 6. So that's going to, I need to add electrons to the more positive side to bring its charge down to be the same. So we're going to add 3 electrons over here, and now each side will have a charge of plus 3. Back to the selenium problem. We will, same story, right? We'll add, there's 3 oxygens on this side, so I need 3 waters to balance those out. That would mean 6 hydrogen ions to balance out those hydrogens. And then this side currently has a charge of 0, neutral water, neutral selenium. This side would have a charge of, let's see, we have minus 2, and then 6 of the positive hydrogen, so that's plus 6 and minus 2, so this side is plus 4, and so I will add in 4 electrons to make the charge neutral on each side. Now I need to recombine these two equations into a single equation. To do that, the electrons have to cancel. The least common multiple of 4 and 3 is going to be 12, so I will then multiply this reaction by 3, and I will multiply this reaction by 4. Then I'll rewrite those down here. So that's going to give us 12 electrons plus 24 hydrogen ions plus 4 CrO3s yields 4 Cr plus 3s plus 12 waters. And this equation times 3, that would give us 9 waters, 3 seleniums, 3 SeO3 minus 2s, 18 hydrogen ions, and 12 electrons. As stated earlier, the reason for the multiplying is so that the electrons will cancel. So I cancel out the 12 electrons, and then I'm going to put all of the reactants together with all the reactants together on one side, all the products together on the other, to make my one overall equation. So that's going to look like 24 hydrogen ions plus 4 CrO3s plus 9 waters, 3 seleniums, 4 Cr plus 3s, 12 waters, 3 SeO3 minus 2s, and 18 hydrogen ions. There's a little bit of reducing that can happen. So I have 24 hydrogens on the reactant, I have 18 hydrogens on the products, and so I can get rid of 18 hydrogen ions on each side. So 18 minus 18 gives us 0, and then that's going to reduce down to 6 hydrogen ions. I think the waters will also do that. We have 12 waters on the products and 9 waters on the reactant, so I can get rid of 9 waters on each side. And so 9 waters gone, that's going to reduce down to 3 waters. And then I can write my overall equation, so it's 6 hydrogens now, 4 CrO3s plus 3 seleniums yield 4 Cr plus 3s, 3 waters, and 3 SeO3 minus 2s. And then I can verify that this is indeed the correct answer by making sure that it's balanced in terms of atoms and that it's balanced in terms of charge. So this equation right here, neutral, neutral, positive 6. So the reactant side is positive 6. And then this guy, we've got 4 positive 3s, that's plus 12, with 3 minus 2s in a neutral, so that's minus 6, positive 12, minus 6. Each side has a charge of positive 6. And then I can just verify that the atoms are balanced. 6 hydrogens, 6 hydrogens, 4 chromiums, 4 chromiums, 12 oxygens, 9 and 3, 12 oxygens, 3 seleniums, 3 seleniums. So this guy is good to go. It is balanced. And if you're wondering how to, this is for an acidic solution, if you're wondering how to make it a basic solution, there's a video where I turn 3 of these into basic solutions. So, or from, just don't turn them, I turn them from acidic solutions and into basic solutions. So check that out.